In a localized, single-server environment, assigning identifiers to your data is straightforward. You give each new entry a sequential number, 1, 2, 3, and the system keeps perfect track of everything. But modern applications rarely operate on a single server. They rely on distributed microservices, where dozens of different nodes process and generate new records simultaneously. That architecture creates a mathematical inevitability. Without a central bottleneck, Server A and Server B will eventually generate ID 45 at the exact same millisecond. The immediate result is a data collision. Two different pieces of information try to occupy the same slot, which corrupts the entire database. Counting upwards simply stops working when an architecture scales outward. Using sequential numbers in a distributed system is a guaranteed point of failure. To solve this problem without rebuilding their infrastructure, developers often outsource the creation of primary keys to external online generators. While this avoids local collisions, sending requests to a remote server for authentication tokens or database IDs introduces a vulnerability right into the base of the application. Every ping to an external tool adds network latency to your generation pipeline. Worse, you have no way to verify if that third-party server logs your keys along the way, exposing your system to quiet, continuous data leaks. Solving a database scaling issue by handing your primary keys to an untrusted remote server compromises the security of everything built on top of those keys. The architectural standard used to resolve this without relying on external servers is the Universally Unique Identifier, or UUID. Version 4 of this standard is uniquely effective because it abandons timestamps and hardware markers entirely. Instead, it relies strictly on cryptographically secure random number generation. The scale of a version 4 UUID is difficult to comprehend. The math allows for 2 to the 122nd power possible combinations. This graph charts the probability of a collision. To reach even a 50% chance of seeing a single duplicate identifier, you would need to generate 1 billion UUIDs every single second for 85 years. Because the available combinations are practically infinite, decentralized servers can generate these identifiers entirely on their own. They never have to ping a central database for permission. To harness this math safely, developers use the Prime ToolHub UUID and GUID generator. The engine operates with a 100% offline client-side architecture. All of the random number generation executes locally within your browser's memory. Zero data is ever transmitted over the internet to a remote server. Privacy and database architecture is a result of total isolation. When the generation process stays local, you eliminate the risk of external interception entirely. The tool handles massive volume. It generates up to 10,000 cryptographically secure primary keys instantly, giving you the ability to seed huge databases. It also adopts to strict backend syntax. You can toggle hyphens, enclose outputs and braces, or switch to uppercase formatting with a single click. For developers auditing or migrating legacy databases, the engine includes a dedicated smart validator. When pasting a list of existing keys, the validator runs them through strict regular expressions, instantly scanning thousands of rows to isolate malformed or corrupted strings. A systems architect can manage the entire lifecycle of a primary key, from bulk generation to syntax verification, in one localized space. When the possibility of overlapping data is eliminated, a database architect can deploy new nodes without configuring complex cross-server synchronization. The system simply scales as intended. Distributed microservices that were once forced to wait in line for a sequential ID can now operate entirely independently, spinning up parallel processes without friction. And this structural stability is locked in without adding network latency or risking data leaks through third-party connections. Data integrity relies on a foundation that is mathematically immune to duplicates and structurally isolated from the open internet. Stop risking your systems with fragile sequential IDs and remote generation. Visit primetoolhub.com to generate your secure offline keys for free today.